So now we can do today's problem of the day question, right? Question name is 1015. The smallest digit divisible by k. Okay, you need to find the smallest integers given a positive k integer, and you need to find the length of smallest positive integer n such that n is divisible by k and n only contains digit 1, right? And these number that contains only digit 1 are called repeats. Okay, now I understand. Let's open the let's do, right? So he's saying 1 is equal to 1, right? And then he's saying inside guys 1 is equal to 1, right? And then third 1 and then it's so our task is to return the length of the smallest such number that is divisible by k, right? So for instance k is equal to 3. 1 second. K is equal to 3, right? The smallest repeat divisible by 3 is 111, right? Since 111 divided by 3 is 37, right? If k is equal to 7, the smallest repeat if 7 is divided by, right, 7 is divided by, right, then we like to 1 5 8 7 3, right? So you return 6. If no repeat can be divisible by k, return -1, right? So the actual number of n might be extremely large and not fit in the standard integer types, right? But you only need to return its length, not the number itself. Then we think what was the intuition that we don't need to store the actual repeat number, which could be massive, but only you need to track its remainder when divided by k, right? Let's think how repeat are built. Like if we expand repeat, right? So 1 is equal to 1, right? And then 1 is equal to 10, 10 plus 1, right? So 1 and then 111 is also 110 plus 1, right? So each repeat can be formed by taking the previous repeat multiply by 10 and adding plus 1, right? So now we see the observation when we checking divisibility by k, right? So we can use using modular arithmetic modular arithmetic properties, right? Modular arithmetic properties we can use, right? So this is like a plus b divided by k is equal to a divided by k, right, plus b divided by k divided by, right. So this means, like, instead of computing full repeat and then checking if it's divisible by k, we can just track the remainder at each step, right? So start with the remainder 1 divided by k, right? And for the next repeat, remainder is equal to remainder into 10 plus 1 divided by k, right? And then we like to think if the remainder becomes 0, right? So we have found a repeat divisible by k, right? Okay, and how do we approach this, right? So let's think. Let's think or implement it. Firstly, we are initialize remainder, right? Initialize remainder like start with n is equal to 1 divided by k, which represent remainder when the first repeat is divided by k, right? And then after first step we should iterate up to k times, right? Then we in this we use loop from 1 1 to k, right, each round. If n is equal to 0, you have found a repeat divisible by k, so return the current iteration number I, right? And I is represent the length, right? And otherwise otherwise calculate the remainder for the next repeat unit. Formula बता रखा है n is equal to n into 10 plus 1 divided by k, right? And then the third step, return minus 1, right? If no solution, right? This is the time complexity is b को k हो जाएगी because we iterate at most k times. The space complexity is big one because we use only a single variable to track the remainder, right? Let's do the code, guys. What was like one second, guys. So end कर दिया, then end reminder 1 divided by k, right? And then we do a loop for int length कर देंगे 1, right? Length 1 कर दी, then length if reminder then we would like to return length, right? And we would like to calculate reminder for x unit, so reminder equal to 10 plus 1, right? Okay, right, and then do return -1. Return -1 कर दिया, right? So I think run the code. Let's compiler error. I think now we will run the code. Wrong answer. In this one is int gradient for int length equals also an let's see. Now it's I think run the code. Let's run the code. Submit the code. Submit the question. So now it's complete. If you ever have any doubt, you can write on comment section, right? See you guys.